Alright, so 2.5 is the last of our topic for macromolecules. And in 2.5 we will learn about enzymes. We ended 2.4 with different functions of your proteins. And one of the main functions of your proteins are catalysis, or they can speed up chemical reaction. Now these protein molecules are what we call enzymes. We can divide this chapter into 3. So we will look at the action of enzyme. How do enzymes work? And we're going to look at what affects your enzymes. Okay. And this chapter is going to end with the applications, the use of enzymes in industries or in food technology. So, actions of enzymes. For any chemical reaction, the general idea is that you have substrates that are reacting, and these substrates will turn into products in any chemical reactions. So, where do enzymes come into play? When we convert substrates to products, we can use enzymes to speed up the chemical reaction. So that's something you've learned from lower school, middle school, to speed up, to make the rate of your reaction go faster. Notice that I write the word enzymes on top of the arrow. It means it is not part of the chemical reaction. It does not mix, combine, nor react with your substrate. It just speeds up your chemical reaction. And how does that do it? So there are some theories behind how enzymes work. One is the lock and key theory. So here in the diagram, what you can see here in black, lock and key. I put lock in. Okay, lock and key theory. The black one is your globular protein. So you have this protein molecule, its tertiary structure, and it's folded. It will have a very important area called the active site. So this area right here. Now, what do you notice with the shape of the active site of your enzyme and the shape of your substrate? Okay, it seems like it's a puzzle piece that you can actually connect here to the active site of your enzyme. This is where we get the idea of enzyme substrate specificity. It means your enzymes will have a specific configuration or a shape that can fit specific configurations of substrate. So if I have another substrate right here, another substrate here, then these two will not fit into this active site. Therefore, it cannot bind. Therefore, your enzyme cannot catalyze these molecules. But this one can fit somewhat perfectly the active site. And once it inserts itself in the active site, therefore, then can your enzyme catalyze the chemical reaction. So how does it happen? So 3 steps you need to remember. First, there should be collision. You have to remember that molecules are constantly moving. So in chemical reactions inside the body, water is normally the medium. So we'll have water molecules around your enzymes and around your substrates. And they're constantly moving. Now if they collide in such a way where this is facing the active site and there's enough energy of that collision, then the next step can happen, which is your chemical reaction. A chemical reaction can either be anabolism or catabolism. So your enzyme can either break apart your molecule, that's called the catabolism, or build a molecule, that's called anabolism. Okay, so let me just show you a diagram for that. Okay, so here's an example of anabolism where your enzyme will collide with its substrate. So upon successful collision, so this will bind to the active site, a chemical reaction will occur here. So your enzyme serves here as a dock for your substrate 1 can react faster with substrate 2. Therefore, they can form bonds faster. Imagine if the enzyme was not there. Imagine this S1 and S2, substrate 1 and substrate 2, are just constantly in motion, moving but never colliding. However, if you have an enzyme, it will hold on to substrate 1, hold on to substrate 2, therefore they're closer. There's more chance of forming bonds between these two substrates. So collision, then chemical reaction, forming of bonds, and once the bonds are formed, you have step 3, I'm so sorry, I forgot to list it down. Collision reaction, step 3 is separation. So your product separates from your enzyme. Again, this is an example of anabolism. You're forming a product from two different substrates. Okay, so again, the 3 steps for an enzyme activity is it needs to collide, there will be a reaction, and your products will separate from your enzyme. So what we just saw was how enzymes anabolize or help form a product. Now let me show you how enzymes help break a product apart. Let me move that here. All right. So the same idea. So you have your enzyme. It has specific shape. This active site has a specific shape that is complementary to the shape of your substrate. And this substrate needs to be broken down. So step 1, collision. So successful collision, it will bind now to the active site. After successful collision, the enzyme will help loosen up the bonds in this substrate molecule. Therefore, that's a chemical reaction, and then therefore here separation. So you have your final products, that is the components, the breakdown components of your substrate. Okay, let's go back. So enzyme action, collision between substrate and enzyme reaction within the substrate, either to form a bond or to break a bond, loosen up a bond. And then separation of your substrate from the enzyme. So this useful aspect of your enzyme can be affected by 3 factors. So we have temperature, pH, and substrate concentration. To be able to understand this, all you need to remember is how to graphically show the relationship of these factors to the rate of reaction of a chemical reaction. Okay, so let's take a look at temperature first. So as you can see in this graph, as your temperature increases, your rate of reaction, I'll put RR, rate of your reaction at first is starting slow, then it will increase, okay, as you increase the temperature. However, suddenly, what happens here? Something happens here. Okay, that's what we call denaturation. This should sound familiar from the previous chapter. So if we keep increasing the temperature, at some point, the temperature is going to be too hot, and it's going to break bonds in your protein molecule. So if I break bonds in my globular folded protein, this will start to unfold and denature. Therefore, this active site shape will also change. If the active site shape changes, it's not going to be complementary now with the shape of your substrate. Then even with sufficient collision, it's not going to be able to bind, since this shape is not complementary to the shape of the active site because of denaturation of your enzyme due to high temperature. So this is high temperature, enzymes don't work anymore, your rate of reaction suddenly decreases, so no more chemical reaction. All right, and then we have your pH. So if we keep increasing our pH, notice that I'm using 3 lines here, or 3 trends here. Y-axis is your enzyme action. Okay, that's enzyme action. What we will conclude in this graph is that some enzyme works best at low pH or acidic environment, while some enzymes work best in high pH or basic environment. And there are also enzymes that work in neutral environments. Okay, so for example, in the mouth, the pH here is neutral. Your amylase enzyme from your saliva works best here in the mouth because it has a neutral pH. Or another example is in your stomach. So your stomach has an acidic pH. However, that pH environment is perfect for your protease enzyme. Protease enzyme works best in an acidic environment. Then another example is your small intestine, where the pH is about 7 to 8, so that's slightly basic. Enzymes such as lipase works best in your small intestine because the pH is slightly basic, and lipase works best in an optimum pH of a basic environment. So what you need to know here are that enzymes works best in their optimum pH. Above or below their optimum pH, they also get denatured. Again, if they get denatured, the shape of the active site changes, therefore it cannot bond or bind successfully with your substrate. All right, so the last one is the effect of substrate concentration. So here in your x-axis, as we keep increasing your substrate, first it's slow, but then it speeds up. The rate of reaction becomes fast until it plateaus or it levels off. So the question is, why does it level off, or why does the rate of your reaction stay the same at some point? Now what you need to know is, of course, if you increase the substrate, there's more molecules to bind with your enzymes, therefore faster chemical reaction. But at some point, like at this point, all of your enzymes are filled or fully occupied by substrate. So there's no available enzyme to catalyze your other substrate molecules. Therefore, the rate of reaction will stay the same. Okay? And until such time that you have an enzyme available, then the other substrates can be catabolized or anabolized by your enzyme. So make sure you know the different graphs and how you will explain the enzyme activity under increasing temperature, under changes in pH, or under increasing substrate concentration. All right, then lastly, we will go to applications. So applications of your enzymes, we have to learn what immobilized enzymes are. So from the word itself, immobilized means it's not moving, it's not mobile. And what they're trying to say here is that once you know the action of your enzyme, so we want to extract all of those enzymes and immobilize these enzymes. Normally, we put them in the form of a gel bead, and there are advantages to immobilizing your enzyme. First of all, if it's immobilized as a gel or a bead, it doesn't get mixed with the solution that it will catalyze. So it's easier to separate your enzyme from the solution that it's catalyzing. Also, if we put them in a solid form, an immobilized form, we can have a higher concentration per mass of that enzyme. And then, so it's easier to use it. It's more stable. So easy to separate from the solution. We can use it in high concentrations, and it's more stable. So it's easier to use. So how do we use immobilized enzyme in the production of lactose-free milk? A quick explanation here. Some people have lactose intolerance, meaning they cannot digest lactose because they don't have lactase enzyme. Lactose is normally broken into your glucose and galactose. Now, some people have lactase enzyme, Therefore, when they drink milk that contains lactose, they can just convert it into glucose and galactose. But some people, actually a high percentage of the population, have lactose intolerance. I have lactose intolerance. And what happens if we consume products that have lactose? We cannot fully break it down into glucose and galactose. So when this reaches your intestine, some bacteria will ferment this lactose and produce gas. So the side effect of this is you're going to feel bloating, you're going to get diarrhea. It's because we're feeding bacteria this lactose that we were supposed to break down into glucose and galactose. However, we do not have lactase enzyme. So how do we produce lactose-free milk so people who, like me, can be able to consume dairy product? Okay, let me show you a picture. Okay, so a simplified model illustration here. So you have immobilized enzymes here, lactase enzyme. Remember the gel beads. So this contains high concentrations of your lactase enzyme, and the idea is you're gonna pour milk rich in lactose through these beads of lactase, and what comes out from the container is glucose and galactose. So assuming as lactose passes through your enzymes, it's being converted into glucose and galactose. Therefore, this is now lactose-free milk. People with lactose intolerance can be able to consume milk products that are lactose-free. Okay, so you have lactose-free milk. Other advantages of converting your lactose into glucose and galactose is that your lactose normally crystallizes, but glucose and galactose does not. So when you're making dairy products such as ice cream, you'll want that smooth and refined texture of your ice cream. So we use immobilized enzymes to convert lactose into glucose and galactose because it's smoother in its texture. Another one is the taste. So glucose and galactose has a higher sweetness level than lactose. So products that needs to be sweet, we turn the lactose of that product into glucose and galactose. And of course, for lactose intolerance, people have lactose intolerance. Okay, so this is the overall concept map that you need to know. Good luck on the test. Bye.